Welcome back. So, after the platelet aggregation, guys, what do we have? We have a full platelet plug, which wraps up the whole second process of hemostasis, which is called the platelet plug formation. So I would like us to have a brief summary about what we've discussed about the second process of the platelet plug formation. Take a good look at this picture. What do we get? We get the primary hemostatic plug, or the platelet plug, or you can just call it the platelet plug. Okay, now what actually happens from the beginning? The first thing we've said that there's going to be the platelet adhesion, which is mediated by the Van Willebrand factor. And the second thing is that before the platelet can adhere, we must have a conformational change from the change of the shape from a disc shape to a spherical shape. And that will happen after the platelet must have bind to the Van Willebrand factor on the subendothelial collagen. They start releasing the content of their cytoplasmic granules. And we talked about those content to be ADP, serotonin, and other substances that helps in attracting more platelet, that help to recruit more platelet to the insulted region that we're talking about here. And when we have more platelet to the insulted region, guys, that is what is called the platelet plug, or the primary hemostatic plug. Okay, you can agree with me that this particular primary hemostatic plug can serve a minor function of reducing or covering the insulted region. But in order to have a very strong covering of that particular insulted or alterated side of the vessels, we need a more stronger reinforcement. So the stronger reinforcement we're talking about here is which is what leads us to the third phase or stages of the hemostasis process, called the coagulation cascade. So the coagulation cascade is actually a very complex physiological process, guys. It has to do with the interaction of several factors found in the plasma. Some of them are synthesized in the liver and then released in the plasma. But the main purpose of the coagulation cascade is to stabilize and strengthen the platelet plug that has been formed. And it does that through the formation of fibrin, which brings about a strengthening of the platelet plug formation, guys. So now let's go deeply into the coagulation cascade. So by definition, you can define the coagulation cascade as a complex biological process which leads to the conversion of the soluble plasma fibrinogen to a fibrin. There are three main stages that constitute the coagulation cascade. The first stage is the formation of the thromboplastin complex. The second stage is the conversion of prothrombin to thrombin. And the third stage is the conversion of fibrinogen to the fibrin. But this particular coagulation cascade, it has to deal with a number of certain factors called the coagulation factors. And we have, if you take a good look at this picture, there's a list that contains all the coagulation factors. There are at least 13 known coagulation factors, and it's going to be a very good idea to have to be familiar and know these coagulation factors very well, because we are going to be mentioning these coagulation factors using Roman numerals. But I believe this particular picture will help you to know the coagulation factors by their name. Okay, the first coagulation factor is we know it as fibrinogen. That's factor number one, is called fibrinogen. The second coagulation factor, factor number two, is called the prothrombin. The third coagulation factor is called tissue thromboplastin, guys. The fourth coagulation factor, we all know it as calcium. And the fifth coagulation factor is called the proacerine, or you can just call it the Leber factor. And the sixth coagulation factor is, we don't have anything like the sixth coagulation factor, guys. It's unfortunate. But we have the seventh coagulation factor. And the seventh coagulation factor is called the serum prothrombin convertin. And the eighth coagulation factor is called the anti-hemophilic factor. The deficiency of this particular coagulation factor, especially the eighth coagulation factor, can lead to diseases such as what? Hemophilia. And the ninth coagulation factor is called what? The plasma thromboplastin component. And the 10th coagulation factor is called what? The Stone power Provost factor. And the 11th coagulation factor is called what? The plasma thromboplastin antecedent. And the 12th is called the H-man factor. And the 13th is called the fibrin stabilizing factor. Then, okay, now going deeply into the coagulation cascade, guys. We have what? Two pathways. We have two pathways. We have the intrinsic pathway and the extrinsic pathways. Okay, now let's take have a good understanding of what we mean by the intrinsic pathways and by the extrinsic pathway. Now, from the word extrinsic, that means the triggering factor comes outside of the blood vessels, guys. And from the word intrinsic, it means the triggering factor starts up within the blood vessels. You understand what I'm trying to say? That's good. Okay, now let's go deeply into what. Let's start with the extrinsic factor because it's more or less a kind of a brief pathway. The extrinsic pathways start with a factor called the tissue thromboplastin, or you can just call it the tissue factor. It starts with what? The tissue factor. Now, when this particular the tissue factor, which is normally found on the on the perivascular endothelial cells. Now, when this particular tissue factor come in contact with the plasma, how does it come in contact with the plasma? It comes in contact with the plasma as a result of what? The damage of the blood vessels. That's the only moment we have contact between the intravascular fluid and the extravascular tissues. So when this tissue factor comes in contact with the plasma, in the plasma, it now converts factor number 7. When it converts factor number 7 to the activated factor number 7, now the combination of the tissue factor plus the activated factor number 7 now convert the factor number 10 into the activated factor number 10. Mark this. Take note of this. Now, okay, now what about the intrinsic pathways? The intrinsic pathway starts with what? It starts with the H-man factor. The H-man factor, which is factor number 12, it converts factor number 11 into the activated factor number 11. But what activates the H-man factor? The contact of the H-man factor with the damage or with the injury to the blood vessels activate factor number 12, which in turn convert factor number 11 into the activated factor number 11. But factor number 11 goes to convert factor number 8 into the activated factor number 8, which is what? The anti-hemolytic factor. Now factor number 8 in turn convert factor number 9 to the activated factor number 9. And factor number 9 convert factor number 10 into the activated factor number 10. If you are really paying attention to what we are saying right now, you get to understand that both the extrinsic pathways and the intrinsic pathways have something in common. And what is that thing, guys? The conversion of factor number 10 into the activated factor number 10. Now, the conversion of this activated factor number 10 into the conversion of the factor number 10 into the activated factor number 10 is what is called the common pathways, because the both extrinsic pathways and the intrinsic pathways eventually convert factor number 10 into the activated factor number 10. So when that happens, the factor number 10 is actually actually guys, the conversion of this factor number 10 by both extrinsic and the intrinsic pathways forms the first stage of what? The coagulation cascade. And if you are really paying attention, you will recall that the first stage of the coagulation cascade is what? The formation of what? The thromboplastin. So the thromboplastin complex is actually a complex, and it's a complex that is made up of what? They are phospholipids, activated factor number 10, together with what? Factor number 5 and calcium. Now, this particular thromboplastin complex has a very, very important role, guys. So before we continue, I would like us to take a break here.